I'm not able to hear you. I believe there is some issue with your microphone or something. Okay. Can you just type in who's that? I don't really understand who's that. Type in the chat box. Basically, I can't understand who's that. Okay. So let's get started with this. I don't really hear that. Yeah, that's what. So I'm just checking things out. So others, everyone is already. So any other thing? Basically, one was trying to not actually figure out who it is. If that is the case, please use the chat box. This would be primarily available for everyone. So use it, and we can actually get things done. Okay. So for now, to mute all your microphones. So just to make sure you have a very smooth transition time towards this. So today's topic would be primarily focused on the later part of MapReduce and understanding the input formats and other high-level concepts. So let's understand that. I'm going to mute your microphones. So in case if you want to raise any question, just type in the chat box. I can actually unmute that. Right. Perfect. So we are ready to go. So let's have the conversation primarily over this chat box. So if you want to interact, I think just type in over there. So basically, we have already seen the basic picture of MapReduce, getting your input data ready and getting things. So getting your whole MR job ready and getting the initial mappers process ready and providing your intermediate key value pair, and then the reducers processing that. So that is what the actual understanding we just got. So basically the next slide would actually take you through some more in-depth detail. So you have something called, can you anyhow actually specify some kind of backup or some kind of optimization technique available here? We have previously seen this example, right? So this example involves some kind of input, a mapper, a shuffle and sort and reduce, and then finally you get the desired output. So basically, how can you make this optimized? Any idea you can actually share or think about it to make this optimized? Anyway, can you actually make this more optimized? So this default picture actually gives you something called you actually process using a mapper. Every mapper throws away something called okay, comma one, brown comma one, fox comma one, whatever be the word that it actually encounters. It actually emits something called the word comma one, that word comma one. So that is how essentially your mapper's output was. And similarly, your shuffle and sort will actually collect all this output, that is all this intermediate data, and then your reducer will actually work out on this. So that is how your mappers and reducer will be executed. But basically, do you feel that this is the actual effective solution here? But the actual standard of mappers and reducer remains the same, but we can still optimize this further by using some function called combiners. So there are a few functions called combiners that will make sure you actually make the whole process more optimized. So let's understand that here you have something called, take a very simple example. Here you have something called d comma 1 d comma 1 d comma 1. So which means you have how many n number of d comma 1s you actually encounter. You just say okay, d comma 1 d comma 1 d comma 1. There is a simple fact we need to understand. What is the calculated value of 1 plus 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 1? If I say that way, like you will have to actually wait for each and every input and then you need to calculate and then output. But rather if I say 5 plus 5, you can literally say 10. So which is faster. Similarly, when you say that okay, this mapper knows how many number of these this is actually going to encounter. So that way, if this fellow can actually reduce this literally locally in this level, so that is what you call it as combiners. Combiners are all reducing functions that is all available locally inside your mappers itself. So that is what you call it as aggregation function. So this will improve a lot of performance in your MapReduce job. The one good example is it can actually reduce your intermediate data size. So when you say d comma 1 and d comma 1 and d comma 1, so which means 4 into 3, which means 12 bytes of data is all being used. But in place of that, if you just say d comma 3, you are just going to use the four characters. So this is how like you can actually see how much data that is all being wasted, or that is all being overused here. So that is what the whole funda behind here is. So if you can actually use this data size would be reduced. So when you say the data size is reduced, the shuffle and sort, the time taken for collecting all the data would be reduced. So and then processing that will also be reduced. So that is what we call it as combiner function. So let's understand how that works. See here, the combiner function is a local aggregation function for repeated keys produced by the same map. So because like most of the time your mapper will also be actually working out on several repeated keys. So that way your combiner should actually come into picture and get things done. So in that way, essentially what we need to actually work out is we have something called intermediate data. When you say intermediate data, the size of the intermediate data should be as minimal as possible. So that is how like your whole MapReduce program will actually progress in a more effective and efficient way. So in that way, like when you actually use a combiner, so this combiner will aggregate all the data, and rather than having several smaller chunks of data, you actually combine it into more sensible data. So that is combiner function will also add value to. And this combiner function is very similar to your reduce function, if you can clearly understand that. See here, your reduce function is something very similar where you get the keys and values, and then the output would be nothing but the key comma the sum of values. Similarly, your combiner also does the same thing but within your mapper. So that is what the difference is. Combiners add value to your actual MapReduce program in terms of performance improvement and also in terms of optimizing your data. So this is what the whole funda behind combiner. So once you actually do the combiner, this was your previous example where essentially you have something called d comma 1 fox comma 1 d comma 1. Using something called combiner, you can actually get this kind of output where you say like this d comma 1 and d comma 1 would be combined together as d comma 2, which means this is what your reducer function is, but this aggregation function happens within your mapper itself. So which means it would be more easier to actually calculate d comma 2 plus d comma 10 plus d comma 5 plus d comma 20, rather than actually having all d comma 1s together as hundreds of d comma 1s and processing that serially. So that is how your combiner function will actually improve the performance of any MapReduce program. Make sense? So when you say combiner, combiner is actually for every mapper there would like when you actually write something called a combiner, combiner is something a part of a mapper. So which means number of mappers equals to number of mappers. Okay, so that seems to be a good question, but that is not really the case. Basically, there are few cases where combiner is available as a reducer function at its own level. So see here, when you actually deal with the higher level, combiner is here used just for optimization. So it is not to actually replace your reducer. Reducer is on the bigger picture. When you deal with 10 GB of data, so the 10 GB of data would be split across into several mappers, and that mappers would be actually picked up, and then your reducer will be dealing with that input data and then process the data and output that. So that reducer will be collecting all the data from several chunks of data and working on the whole picture. So that is what reducer is. Reducer is primarily meant to derive at the outer final desired output. While on the other hand, when you say map function has something called intermediate key value pairs, right? So this data is all primarily here. We are not going to derive any output. So take a very simple example. You are saying, okay, just because we are doing reducer here, why do we need a reducer? There is nothing but a kind of aggregation function what your reducer does within its own entity. So within its own data. So that is what here. If you say you are going to ask a word count for 1 GB of data, I'm going to give a word count for just this chunk of data. Will you accept that that is the output? No, that is not the output. Here it is just another intermediate data, but it is more optimized. Does this answer your question, Shivraj? Yeah. So that is what the funda here is. Like basically, just combiner is nothing but a part of a functionality extended as your mapper function. Which means whatever is applicable for map will also be applicable for combiner. So combiner is nothing but an extension of your mapper. So it would be a part of your mapper, combiner. Combiner is a function that will be executed once just after your mapper function completes. Actually move to the next topic. Now actually going to see something called map reduce input formats. So this map reduce input formats is quite relevant in terms of understanding why how your input data is all represented as key value pairs and how it is not your usual raw format. So let's understand that how it works. So previously in this session we have already seen something. See here, this was a standard that we have seen, right? So your data type is your key value pairs and your mapper function. Your map function involves something called key value input key value pair, and that input key value pair would be actually used by your mapper function. The logic of your mapper function will throw away something called intermediate key value pairs. This would be used as an input for your reduce function, and reduce function would throwing you an output. So that can be that can be in any format that you might want. So basically, when you say this input format, this input is read in terms of key value pair. How does this? So this is something you'll have to understand. But basically, you can actually question. I'm going to give an input data as a text file. So how it is all being represented as a key value formats. So let's understand that here. So you have something over here called input formats. So you have something called the default text input format. By default, when you don't specify anything, the input format that is all used or considered by your Hadoop system is what you call it as text input format. Text input format is your default format where essentially you can actually read each and every line of file as one record. Specifically where does the key comes into picture is what like you will have to understand in the next slide. Basically like the delimiter would be like /n or your carriage return, so which means one single line would be used as one record. And what is a key would be like it is key is a random value, you can understand that. So here if this is the input file that you actually read with, so this input file would actually get this key value pair as a representation what your Hadoop will be reading as. So this is what the input you will be giving. But when you say the input should be in terms of key value pair, Hadoop will be reading that as some line word offset, they call it as 0 comma value. This value is nothing but your actual input files first line. So this is one record, this is the next record. So here 32 is clearly not your line number, but essentially they call it as word offset or line offset. So which means after 33 characters the next line starts with. So that is what basically we are not really concerned about this key. but the standard way is to actually get any data on board using something called key value pair. So that is how this input key value pair would be represented. Right. So once you actually get this done, you have something called, so you get this intermediate key value pair. So once this intermediate key value pair is all ready, you actually take this as input and then process that, and you actually get the output ready. So that is how the fun, or that is how it evolves. You have something called key value text input format. There are few formats essentially that does not really involve that might actually have the key itself inbuilt. You don't really need to actually deal with something called key, but there are few input data types where you might actually get the key itself. So here previously in your text input formats, the keys were literally nothing but the offset within the file, which means nothing but the line offset or word offset, all it has. And they are primarily not really useful because like we are more concerned about the data. So in terms of word count, that is not at all useful. But there are few other scenarios, or there are few examples where you might have the key itself already in the data, which means one good example is your log file. So where in your log file, your key would be like you want to actually use some IP address, which is all unique as a key, and then the corresponding description or some attempt towards actually logging in that as a value. So in that sense, the file itself has, each and every record itself has something called the key and the value. So in that way, you need to understand something called key value text input format here, which will give you a clear picture on how your key and your values are all represented as. So you can actually specify the separator by using something called your mapreduce.input.keyvalue in line record reader.key.value.separator property. So these are all some kind of properties available from your Java API, so that can be used to actually replace some delimiter. So sometimes your delimiter, the default delimiter is tab character, but when you want to override that, there are few files which might have the delimiter file to delimiter data to be semicolon. So that way you need to understand that. So here like this. So basically, if you have this, let me actually open this. Has there is a typo in that. So this is how it will work out. So when you say a key value text input format, this key value text input format will actually throw you something called, this is what the file is, which the file contents would be like some data, line 1, tab character, and then some value. So here if you clearly see that okay, this line 1, line 2, line 3, line 4, these values would be used as a keys, you can still use something called key value